and welcome to the WSWHE BOCES Network Team webcast. We're going to talk this morning about the mathematical shifts found within the Common Core. And at this point, if you haven't seen the Dan Myers clip from the TED Talks, I'm going to switch to a slide with a link there, and you should pause your webcast at this point and watch that 12-minute video. He asks a lot of questions around our math classrooms and if our math classrooms need a makeover. The link can be found here. So again, if you haven't seen this, he's a high school math teacher out of Santa Cruz, California, and he has some great thoughts around how we can use the resources available to us to make math more engaging for students. Okay, welcome back. Hopefully you gained some insight into how math classrooms can start to shift from Dan Myers' talk. We have a culture in the U.S. that often fosters math anxiety in our students. There was even a Barbie doll that used to say math is hard. A lot of times we'll hear people say to their students or to their own children, it's okay if you're not good in math, I wasn't either. Or, oh yeah, math is really hard. We hardly ever hear that around literacy and reading. And this is a shift that needs to happen within our culture, where we become more focused on math and see the value in our everyday practice. There are some ideas from the psych files around how to avoid math anxiety in our students. It starts with building the attitude towards math that math doesn't have to be hard. It's about problems and problem solving. And the more we can engage kids in that thought process, the more likely they are to engage in those practices. It's all around problem solving, working together with students, modeling how to attack problems, what types of questions you may want to be thinking. When students kind of come to a stumbling point or a wrong answer, we've got to take that constructive approach to saying, well, what do you think this could mean? Or how else could we go about this? The idea here is to get kids engaged and excited around mathematical practices. Dan Myers talked about those makeovers in our classrooms, and it really starts with the connection between our content and mathematical practice. The bullets on the screen represent the mathematical practices that are found in the Common Core state standards, and these are consistent across our K through 12 classrooms. To help frame the implementation of Common Core and to really make the connection between our content and the mathematical practices found within the standards, we've been given 6 instructional shifts to help focus our efforts in the classroom. The first shift within mathematics is focus. The idea here is that teachers are going to be able to really look at their curriculum critically, find those areas of excess, and really narrow their focus within the classrooms to build fluency, to build students' knowledge around those important math concepts. Students will be spending more time thinking and working on those areas of focus, and therefore be able to understand those concepts at a deeper level. This slide represents those areas of focus for K through 8. You'll notice at the K through 2 level, it's building the idea of number sense, whole numbers and their quantities, addition and subtraction. As you move towards 3rd through 5th grade, we're focusing on the use of multiplication and division to solve problems, and also the work with fractions, which would lead into their understanding of ratios and proportions at the 6th, 7th, and 8th grade level. What we're hoping is that by the time students are completed in 8th grade, they're able to really understand the concepts needed for their algebraic reasoning. As you look at Math Shift 2, it's talking about the coherence within our curriculums at a particular grade level and also across grade levels. We want to ask ourselves, how does the work that I'm doing affect the next year's work for students? How do these standards build on previous standards that students have seen? The idea also is for students to be able to build their knowledge from year to year and also within the year. So as we're working with multiplication, you start to think about how can this build into students' ability to work within area and geometry. Math Shift 3 is about the fluency that students will have around particular skills. It's the mathematical content that students should know quickly, and it allows them to get to the application level much faster and to really dig into understanding concepts more deeply. The idea here is to push students to know those basic skills and facts at a younger grade level, and to then build on those through application within your classrooms. So the next slide will show us what those fluencies are outlined for each grade level. You'll notice that at the kindergarten, first grade, and second grade level, they're talking about the addition and subtraction again, which was the area of focus within the standards. Same idea at third, fourth, and fifth, where the fluency is around multiplication and division, which is also that focus area within the standards. And as you move to 6th, 7th, and 8th grade, it's not necessarily their ability to cite the answers to problems quickly, but it's their ability to work through the procedures in solving multi-digit multiplication or division, or work with decimals quickly. So you'll notice if you're comparing these fluencies to your own grade level standards, the standards oftentimes ask kids to work with larger numbers than what's reflected here. The idea is that these fluencies are the minimum standard that kids should have automatically at the snap of a finger be able to give you that answer. I'm going to talk about two specific resources that can really help address shifts 1, 2, and 3. The first of which is the PARC Model Content Frameworks. This is a guiding document meant for both teachers and curriculum designers to give you some idea around the focus and coherence within individual grade levels, and also to highlight examples of the concepts and what they could look like in actual practice. The K-8 model is set up by individual grade levels. At each grade level, you'll see key advances from the previous grade so that you can start to know where are your students coming from and how can you build off of that. The document also goes further into the explanation of the fluencies that we outlined within Shift 3, and you'll also see many examples and narrative around those within grade dependencies and the opportunities for connecting the mathematical content to mathematical practices. This chart here is a representation of what you would see at each grade level in K-8. The green squares represent the areas of major focus and clusters that should be emphasized within your grade level. This can help both teachers and curriculum designers as you're starting to outline a year and decide where time and energy and resources should be spent. The blue squares outlined are the supporting clusters. Those are the types of standards that can be built into the work with the green clusters. So if you look underneath this measurement and data example, the green major cluster is the idea of solving problems with measurement and estimation, and the blue square that would help support that work would be representing and interpreting data. The high school section of this document, the PARC Model Content Frameworks, is set up a little bit differently than the elementary. The standards are organized by conceptual category versus grade level, and within this entire section of the document, it's split into two sections. You're going to see a general analysis of the math standards and then more course-specific analysis as you go through. The course-specific analyses are not meant to be seen as a fully formed course, but they're rather to provide initial high-level guidance as to how you can structure a course. As you read through the general analysis at the high school level, you're going to see examples of opportunities for connecting your standards and your clusters, just as you did at the elementary level. You're also going to see examples of how the standards apply in more than one high school course. When you dig into the specific course analysis sections, each course will start with a narrative giving you a sense of the course as a whole, and then they will break it down into examples of the key advances from previous grades or courses, the fluencies recommended at a high school level in terms of students' ability to work with mathematical content, and then you'll see other examples of how to build your major course dependencies and the opportunity for focus within your courses. This chart is just an example of what you would find within the general analysis at the high school level. The purple area represents the one math standard, and then it shows you how within Algebra 1, Geometry, and Algebra 2, this standard could be approached. There are many other examples of how standards are cross-content and cross-course relations. The second resource I wanted to give you to work within shifts 1, 2, and 3 would be the progressions document, and this is out of Arizona's education department. It's a narrative document that helps describe the progression of topics across a grade level, and it's informed both by research and actual practice, the logical structure of the math standards. It is a work in progress, but it is updated regularly. People that we've worked with in workshops have found this helpful in pointing out where student misconceptions could be and how to address those through their instruction. So it's worth time taking. You can follow the link below to the document itself and then navigate throughout your individual grade levels or coursework. As we head back to the other math shifts, shift 4 is around deep understanding for students within their own mastery of the material. And this actually starts first with the teacher having that deep conceptual understanding. So oftentimes we're going to need to go back and seek out professional development or further learning around these math concepts so that we can then translate that to students' deep understanding. The assumption here is that students will be able to find the right answers through a number of different routes, that they'll be able to articulate their math reasoning. How did you get there? Why did you choose this path? And then also be able to be fluent in the necessary baseline concepts to be able to get to this deep understanding. So this shift is really connected with shift 3 in those fluencies, as well as shift 1 and those focus areas for your grade level or course. Shift 5 is looking at the application of these math concepts and those focus areas for students. In college and career, students will often have to solve problems without being prompted as to how or when to solve those. And so the teacher's job here is to really provide students with those real-world experiences so that students are able to apply math, both in the math classroom and across other content areas or situations. A great model to really help explain how this can look within a classroom is Bill Daggett's application model. When we look at this, it's also called the Rigor and Relevance Framework. I'm going to walk you through some slides, but this is a great model that can help teachers and curriculum designers provide students with those real-world application in the math classroom. As you go up the vertical axis, we're looking at the increase in the knowledge level of students. So you can think of this as Bloom's taxonomy. Across the horizontal level, we're thinking about the application of these concepts. Towards the left would be within the discipline types of applications. And as you move across, it would be across disciplines. And then finally at the far right would be those real-world unpredictable applications. To connect this to our math concepts, we're going to look at quadrant A first. This would be the low level of knowledge around students and also within the class or discipline application. So looking at some of those examples, you can see here, these would be typical things, the building foundations of math concepts within your math classrooms. As you move to quadrant B, we're moving across the horizontal axes, which again was that application level. And so it's still low level understanding of the math concepts, but students are starting to apply that in the real world and across discipline situations. So looking at specific examples here, you can see that they're broadening their horizons by working with newspapers, the idea of working within the school building and not just one classroom, and looking at actual data from histograms or other displays. As you move to quadrant C, we're now moving up the knowledge axes on the left, and we're still within the content discipline areas. So this is often where our AP classes were. High level of knowledge, but it's within a discipline that students are applying that knowledge. And then finally, quadrant D is our ideal goal. This is where we want our curriculum to help students gain knowledge and expertise. It's the high level of knowledge, and it's that real-world, unpredictable application of the knowledge. Many of the IB courses are built around this foundation and philosophy. Now those slides have shown you some examples of how knowledge and application can be brought together, the idea of bringing content and practice together. These two links will also bring you to some other areas for illustrations of how math can be brought to life. The first is another clip from Dan Myers, and he has some great examples of how real-life situations can be brought to life in the high school classrooms. And the second link is really just a re-emphasis of how math can be found in everyday lives, particularly at that elementary to early intermediate level. The final shift is shift 6, dual intensity, and the idea here is finding the balance between both fluency and the application. Students need to have time for both within their classroom, and lessons should be built around students practicing both the fluency and the deep understanding through application. This graphic really just helps emphasize shift 6, and we're going to talk about one other resource that could be helpful as you're trying to build curriculum and instruction around this idea. The Illustrative Maths Project is also a work in progress, but a great resource worth delving into to help find what does this look like in a classroom if I'm trying to faithfully implement the Common Core. You'll see actual class examples of student work problems. They talk to you about the possible solutions and possible student misconceptions as well. When you go and visit this link, you'll see that it's broken down into the K through 8 content standards as well as the high school standards. You're able to click within those subcategories and narrow in. You'll see if there are illustrated standards, you could click on the link here. And again, it's a work in progress. There aren't examples for every possible scenario, but it is updated regularly, so it would be one you want to keep on your favorite list. So some final thoughts around this. The National Mathematics Advisory Panel was asked to think about and look at math instruction across the U.S., and they came up with about 15 suggestions and recommendations, some at the classroom level and others at the more national and curriculum level. But as you look through, it really emphasizes and validates the work that we're doing around the Common Core standards, the shifts when you're talking about the fluencies, and the idea of focus. As you look at the second half of those recommendations, I think number 8 and 9 are important to note. These are paradigm shifts for both students and instructors. As we look at shift 8, it's the idea that math is not necessarily about your innate ability, but there should be the focus on the effort that's put into the process. It goes back to those first few slides around math anxiety and really building students' ability to problem solve and look at math from an exciting puzzle type of frame of reference. Number 9 is about that instructional paradigm shift for teachers. Often when we look at the new standards, we think, are kids ready for this? It seems that they're maybe too young for this. And instead, we really need to think about what experiences are needed first. And that goes back to shift 2 when we talk about the coherence of the standards, understanding where students have come from and being able to build off of that, either within your own grade level or across grade levels. So getting back to Dan Myers and his idea of a math classroom makeover, these would be some milestones. You'll know that your implementation of the shifts and the Common Core have been successful when you start to see students explaining the meaning of a problem or looking for different solutions to problems that are presented to them. Students will be able to start explaining and searching for regularity or trends, explaining how they arrived at a solution. And they'll be able to check their answers with various methods. So I'm going to leave you with thinking about what are the next steps for your own classroom in terms of the instructional shifts and the actual standards. And I encourage you to visit our website, and on the Common Core subpage you'll find a great resource put together by Steve Dana, the must-see math resources. On that link you'll see the three that we've talked about, the PARC model content frameworks, the learning progressions document, and the math illustrative project, but there are many other helpful resources. So thank you and good luck.